In this question, we're given a graph of a linear relationship that represents the total cost of a day at the fair on the vertical axis versus the number of rides taken on the horizontal axis. And we're asked to determine which of these equations represents that relationship. So C is the total cost, and R is the number of rides taken. So given that this is a linear relationship, the equation can be written as C, or the vertical axis variable, is equal to the rate of change times R, which is the horizontal axis variable, plus the initial value. So what we need to do is find the rate of change and the initial value from this graph. So we know that rate of change is the slope of the line, and it's given by the rise over the run. So let's go to the graph and we'll pick any 2 points, say this one and this one, and what we can do is figure out how far over do we have to go and how far up do we have to go. So if we went from here over and up, this would represent the rise and this would represent the run. So for the rise, we're starting at 35 here and we're going up 1, 2, 3 units, 35, 36, 37, 38. So the rise is 3. And for the run, we're going from 3 to 4, which represents 1 ride. So the run is 1. Note that even if we're going over 1, 2, 3, 4 units, each of the units on the graph represents a quarter of a ride. So our rate of change here is 3. So the rate of change should be constant in a linear relationship, so we can verify that. If I started from this point here and went from 2 to 3, that's 1 unit as a run, and then up 1, 2, 3 for a rise to get to the next point, we can see that the rate of change is constant. Next, we have to determine the initial value. One way to do it is to draw a line through the points we have as best we can, and then see where the line crosses the vertical axis. So our initial value would be this point right here, which looks like it's about 26 and a bit. The value we get would depend on how well we drew the line. So there is another way we could do it in order to be more precise. Let's remove that line and we'll use the constant rate of change to see if we can get a better value. We'll note that as we get from this point to this point to this point, we went down 3 and over 1. Down 3 and over 1. So we can continue that process and draw points until we get to the vertical axis. So from this point, down 3, 1, 2, 3, and over 1, we'll see that we get a point right here. And we can keep going, constant rate of change, down 3, 1, 2, 3, and over 1. We get a point right there. And that point is right on the vertical axis, so that represents our initial value, and that would be 26. So the initial value is 26. And because we now have more points, we can draw a better line through this data. So now we have all the information we need to get the equation of the line. Our rate of change is 3, and our initial value is 26. So let's put those values in our equation. The rate of change is 3, and the initial value is 26. And so the equation would be C equal to 3R plus 26. And if we look down our list of options, the answer is D.